Okay, for number 10, the problem says find the vertex, the focus, and directrix of the parabola with a given equation, and we have our equation here. So let's recap a couple of things. If our parabola opens up or down, it's going to have the equation x minus h squared equals 4p times y minus k. Recall, p is the distance from the vertex to the focus of the parabola. If p is positive, it would open up. If p was negative, the parabola opens down. If the parabola opens to the left or to the right, the equation is very similar, except the x's and y's kind of just switch places. So I would get y minus k squared equals 4p x minus h. And again, if p is positive, it would open to the right, and if p was negative, it would open to the left. Okay. So to get this equation here to look like this over here, we want to first of all identify what variable is being squared, gather those terms onto one side, and complete the square. We want to move all the other terms to the other side, and then we're going to have to factor something out so that the y or the x will have a coefficient of 1. Then we're going to take that factor and split it into 4 times something, and that will be the p-value. So here we go. First of all, I see that it's a y squared, so this is going to open left or right. We don't know which direction yet, but we'll come back towards the end of the problem and be able to figure that out. So again, I'm going to gather the y squareds, and I'm going to move the other terms to the other side. We are now going to complete the square, so we take half of this middle term, negative 3, and we square it, and we add that to both sides. So I'm going to add 9, add 9. This side now factors into y minus 3 squared equals, and I have negative 20x minus 40. So our left side is complete for right now. We just need to work on the right side a little bit. Again, I want a coefficient of 1, so whatever is in front of that x, in this case the negative 20, we're going to factor that negative 20 out. When I factor that out, that leaves me a 1x here. When I factor it out of the negative 40, that leaves me a plus 2 here. My last step is to split this negative 20 up into 4 times whatever that p-value is. So 4 times, in this case here, negative 5 will give me the negative 20. So my p-value is negative 5, which now means I know, going back up here, this graph is going to open to the left. This parabola will. So from here, we can determine our vertex, we can determine our focus, and we can determine our directrix. Our vertex is always what we subtract from x, comma, what we subtract from y. Recall, our vertex here is going to be, in both of these cases, h, comma, k. It's what we subtract from x, what we subtract from y. So in this case here, because it's x plus 2, we are subtracting negative 2. Because it's y minus 3, we are subtracting 3. So our vertex is negative 2, 3. Our focus is then going to be 5 to the left of this point. Now if you want, this is where maybe a little bit of a sketch comes in handy. So negative 2, 3. There's our vertex. And I want to go 5 to the left of this. I think you can see at that point it would be out here. That's our focus. And it would have coordinates negative 7, comma 3. Finally, our directrix. Now recall, our parabola is going to look something like this in that it opens to the left. Our directrix then would be over here to the right, and it would be a vertical line. Therefore, it's going to be x equals, and it would be 5 to the right of that point. Well, since this point is at negative 2, moving 5 to the right puts it at positive 3. One of my students suggested that whatever letter changes here, either x or y, is what we will use as the directrix. Sure, that works. But ultimately, the directrix is always going to be perpendicular to the axis of the parabola. And so we have our vertex, we have our focus, we have our directrix, and we're done with this problem.